This is a lesson on finding the slope of a function in polar coordinates. Traditionally, a point in two-dimensional space is represented using Cartesian coordinates. Each point has two coordinates, which correspond to the x and y axes. Another way to represent points in a plane is by using polar coordinates. Instead of having an x and a y coordinate, every point has an r and a theta. R stands for radius, and it's equal to the distance from the pole, which is this point here, to the point. And theta is the angle made between R and the polar axis. So this point here would be roughly 2 pi over 4, because the radius is 2 and the angle is pi over 4. It's important to realize that unlike with Cartesian coordinates, points in polar form do not have a unique address. This means that two or more different coordinate pairs can describe the same point. For example, this point is we'll say it's 1 pi over 6. But it can also be written as 1/13 pi over 6, because this angle here is not only pi over 6, but it's also 13 pi over 6 because it's one rotation later. There's an infinite number of ways to write this angle. And you could also write this point as -1/7 pi over 6, because you could trace this angle. This is 7 pi over 6 right here, and then you just go -1 in that direction, so you get the same point. You can convert polar coordinates to Cartesian using simple trigonometry. For example, for any point r theta, the radius becomes the hypotenuse of a triangle. So r, and the legs are x and y, and the angle is theta. And you can derive formulas such as x equals cosine theta, y equals r cosine theta, sorry. So x equals r cosine theta, y equals r sine theta, and x squared plus y squared equals r squared. And another thing you can do with polar coordinates is represent functions, just like in Cartesian coordinates. But the function is usually r in terms of theta, or it can be r not in terms of theta. So a simple function is r equals 3, which is just a circle with radius 3. Theta, no matter what theta is, r is always 3. Or if r is in terms of theta, so r equals theta. As theta increases, r increases. So you start out with theta being 0 and r is 0, and then gradually it spirals greater and greater. In Cartesian coordinates, you can find the slope of a function at any point by finding the derivative, dy over dx. To find the slope of a function in polar coordinates, you have to find dy over dx as well. Let r be defined by theta. So r equals f of theta. This basically just means that r is some function of theta. Dy over dx equals dy over d theta over dx over d theta. And we're going to use the equations that we derived in the last segment. X equals r cosine theta and y equals r sine theta. And we'll plug those in for y and x. So d over d theta r sine theta over d theta r cosine theta. So what we need to do now is just derive these functions in terms of theta. And we'll use the product rule to differentiate. So we will get r cosine theta plus r prime sine theta over negative r sine theta plus r prime cosine theta. And so I'll do an example using this equation.